Hey everybody, this is Mr. Beckstrom, and today I'm going to look at an example from section 9.1. This is number 16, and it says the rectangular coordinates of a point are given. Find polar coordinates r theta of this point with theta expressed in radians. Let r be positive and let theta be between negative 2 pi and positive 2 pi. And kind of give us a larger than normal range there. And the point is 2, negative 2 root 3. So let's first thing kind of see where that point is, and then kind of see our expectations of where that r and theta is going to be. So if I just kind of do a little makeshift graph here, it goes positive 2 in the x direction, and then it's going to go in the negative y direction, 2 root 3. Let's just see how far that is. Negative 2 times the square root of 3. So that's about 3.5. So 1, 2, 3, 4. So maybe right around here. So this is the point that we're talking about. So to get this into polar coordinates, we need to know the measure of this angle here and the distance of this radius right there. So the distance of the line from the origin to that point, 2, negative 2 root 3. That's going to be our r, and then the theta will be the angle going into the fourth quadrant there. So we should expect some angle in radians that's in that quadrant there. All right, so let's go ahead and get working on this. The radius just uses that distance formula, so that's just going to be equal to, the radius is equal to the square root of each of these values squared. So 2 and the sum of those, 2 squared plus negative 2 root 3 squared, so that's just equal to 4 plus, and this thing squared, so that's going to be 2 times 2 is 4, root 3 times root 3 is 3, so 4 times 3 is 12. So this is just going to be the square root of 16, which is equal to 4. So the distance from the origin to this point here is 4. And that looks about right. That looks about right. It's just kind of a quick estimation to make sure that my values don't look way off here. But so that's my r. And then my theta, so remember my theta needs to be in the fourth quadrant there. And I always like to use the tangent function to find it, because if it doesn't give me the right quadrant, then I can easily add 180, half a circle, to put me in the correct quadrant. So for that, the theta, I just use the inverse tangent of y over x, and like I said before, it'll either put me in the correct quadrant, because remember the domain for inverse tangent is the first and fourth quadrants here. So if my angle is already in the first or fourth quadrant like it is, then it's going to give me the correct quadrant. If my angle happens to be in the second or third quadrant, then it's going to give me the one opposite it. So for example, if the angle is in the third quadrant, using this formula here will give me the one in the first quadrant, and then I can just add 180 degrees and it'll give me the angle or a coterminal angle in that third quadrant. All right, so I have that in there. So this is equal to the inverse tangent of negative 2 root 3 all over 2. And this can kind of reduce that to inverse tangent of just negative root 3. All right, that's good enough. And I'll use my calculator for this. And I'm going to go ahead and make sure I'm in degrees, just because it's kind of hard to tell when you're in radians. Because if you get a If you're in radians and you get a square root, it's not going to give you the square root. It'll give you an approximation, and then you have to kind of guess what that square root is. So it's much easier to find your answer in degrees and then to convert it over to radians later. So if I go over to mode, I am in degrees, and then I just do the inverse tangent of negative second square root of 3, second square root of 3. That's going to give me negative 60. Now, that is in our domain here, so that answer would be fine. I'm going to go ahead and put this in standard form just because standard form between 0 and 2 pi is also in our domain. So I'm going to go ahead and add 360 to it. I don't have to for this one, but might as well. So that's 300 degrees. But they want in radians, so the equivalent radians for 300 degrees is 5 pi over 3. So this is equal to 300 degrees, which is equal to 5 pi over 3. So my final answer would be 4, 5 pi over 3. And it should have also taken the negative 60 degrees, which negative 60 degrees, so we probably could have also answered for negative pi over 3. Pi over 3, that would be negative 60 there. So both of these should work. Anyways, if you have any questions, let me know. And I hope you have a great rest of your week. Good luck on the test.